All right, friends. Nice to see you all. Happy Tuesday. Rainy. Kind of rainy. Tuesday. So we're gonna. Uh-oh. I got the number right. Why are we choosing not to enter the waiting room? 10423. It's been the same forever. Enter waiting room. Well, that must mean one thing. There's an update. Oh, there's not an update. All right, looking good. We also. All right. There we go. All right, so yesterday I ended on, I forget. How much?
We finished 6-3.
Finished 6-3, so we are on to 6-4. All right, so you know that on this test come both Thursday, Friday, which I won't be here for, I'll make sure I have the graphing calculators available so you can have that, and I'll have the extras from Mr. Peterson. But Mrs. Hogue will be your sub. She's a former math teacher from here. I don't think I have to warn you like I warned my CP Algebra 1s. Just don't have your name as one that's listed for the sub. I have few pet peeves in life, but one is when I have a sub, even though, if I was one of those teachers who's out every third day, I get it. But I'm not out that often. So please don't become one of those students that gets on the list, because I won't like you. All right, so I'm on, it looks like page 27. Any of these stuff for your notes, you can use your notes. You don't have to worry about making note cards. You can use your notes on both parts of the test on Thursday and Friday.
Can you use old Word?
Yeah, anything that is part of your, I would just ask this. Do not go start sharing back and forth. If the person next to you is like, I didn't bring anything in class, sucks for them. Okay? But we'll figure it out. If you don't get finished, don't panic. Okay? If you don't get finished with something, don't panic. Yes, you'd have to finish it up with me, but don't panic. If you don't finish, do me a favor. If you don't finish, you have your name at the top. If you didn't finish, just do this for me. Put a smiley face next to your name. So when I come back on Monday, I can go through it and pull all the ones that have a smiley face and say, okay, we can use extra time. Don't turn something in blank with a smiley face. That means you're not really trying. So, deal? All right, so then we start getting into the type 1 and the type 2 error. Type 1 and type 2 error on page 27. Okay? And the type 1 and type 2 errors are just things that could happen even though our research showed differently. All right, so let's do type 1 error. Okay, we reject a null that is really true. Okay, and a type 2 error, we fail to reject a null that is really false. And I heard this. So fail to reject the null that is really false. So let's do this. We reject the null. So that means that there's evidence. No, I don't want to do that. We reject a null that is really true. Okay, so remember we have our null and our alternative. This is what we're testing. This is our null. Okay, I've heard if you were to think about like the jury system, somebody is on trial. Are there people who were put into prison who were actually innocent? Yes. Were there people who were actually guilty who were released? Yes. I mean, those are basically your type 1 and type 2 errors in a court of law. Okay, so we reject the null. So if our null was, H naught is equal to 70, let's say we're looking at test scores out of 100, I don't know. We reject the null that is really true. So we said, this was really true, but somehow through our testing or our statistics, we rejected it. So this could be, in this case, person is committed a crime. Everything about them is pointing to that it should be, but they got off. It was rejected. And your generation is really guilty on this, actually, this whole nationwide thing. How many times has something come across on social media saying, oh, that's so true? And it goes through the courts, and the courts decide different than what you felt because you saw it on a TikTok. I heard a situation that there was a couple of teachers who were recorded in a private conversation, which I don't know if you know this, but it is illegal to record a conversation that you are not part of. And the person that edited the video put snippets in place that takes certain things out of context. And it got back to a student's parent. And I mean, these teachers are pissed. Which you should be, because it was manipulated to, I mean, if a teacher came in to me and says, hey, I need to talk to you about Billy. Oh, yeah, Billy. I mean, it's possible that, I don't know who Billy is. I'm just making up some arbitrary name that came up in my head. But any one of you could record that conversation and manipulate it, and you could change, my 15th word and my 35th word of my conversation, and all of a sudden it says, Billy is a loser. Might not have been the context it was in, but you manipulate it, make the person look bad. Yikes. All right. So on page 27, it does indeed, you have to know the type 1, type 2 error. Global warming is not occurring. Global warming is occurring. Your null is it is not. Your alternative is that it is. If this was a type 1 error, that means we found strong evidence for global warming that's not actually occurring. The consequence for our study making a type 1 error might be that we promote expensive, cumbersome laws that aren't needed. Okay, that could be, I'm not saying. And then type 2 error, this means we failed to find strong evidence that global warming is actually occurring. The consequence for making a type 2 error is we might be too slow to respond to significant change of our climate. Okay, and I'm not trying to get on political stances with anything. I'm just saying that there are definitely things that take place. I'm on page 28 looking at example 3, and it says, let's say we are studying whether or not a daily aspirin in older people reduces risk of heart attack. So your null is daily aspirin has no effect on heart attack risk. Aspirin? Yeah. I don't know. I bet you we could find it both ways on the internet. Aspirin is?
Yeah,
Salicylic acid?
but I don't know what organ is that for. It might be the third one.
Ibuprofen and
What's your
Tylenol.
number, Gia?
Ibuprofen and Tylenol are bad. Aspirin really doesn't have too many bad effects.
Tylenol, aren't you supposed to take it, but aren't you supposed to try and give somebody an aspirin if they're having a heart attack?
Yeah.
Oh, yeah, you're right.
So here's the big difference between painkillers of aspirin, Tylenol, and ibuprofen. The reason aspirin seems to take so long to react is aspirin is actually absorbed once it makes it through the liquid form by you digesting to your bladder, and it's absorbed by your bladder. Ibuprofen and Tylenol are absorbed by your liver. What comes first and as things go through? Liver. So, yeah, ibuprofen and Tylenol. I think Tylenol is worse. I think Tylenol, you can actually take a lethal dose of Tylenol and it'll shut your liver down, which, we've all come across that person going, yeah, I took 15 ibuprofen just now. Should get rid of the headache. Okay. Bad idea. So let's see. If you make a type 1 error on page 28 with the aspirin, this means we found strong evidence that daily aspirin lowers the risk of a heart attack when it really does not. Consequence for our study, making a type 1 error might be that older people will needlessly take aspirin every day. Okay. If we made a type 2 error with that same thing on page 28, it says this means we failed to find strong evidence that aspirin reduces the risk of heart attack when it really does reduce the risk of heart attack. The consequence for making a type 2 error is we must miss the opportunity to prevent a heart attack. Okay, so sometimes a type 1 error might not be a big deal. In that case, it's just the aspirin company's making money based on people taking it. And if aspirin doesn't really have too many side effects for you, then then you're just making a company richer. Type 2 error, you might have missed. So sometimes type 1 versus type 2, could be big deals. Page 29. Page 29. There's an awful lot on page 29 that I would definitely make sure you have indicated. The lower the p-value, the stronger the statistical evidence against the null. Ooh. The lower p-value. The lower p-value, the stronger evidence against the null. Evidence against the null. Would one of you help me spell one of these days? Just can't read. So lower p-value, the stronger evidence against the null. Lower p-value. So p-value being like really low, like a really tiny decimal, the stronger the evidence is against the null, because the null is what you're testing. When does the p-value become low enough that we decide to reject the null and claim strong evidence in favor of the alternate? So this is the one where we are looking at, is our p-value less than 0.05? And that just becomes something that we have said, hey, if you're at this, that's a good spot. Okay. Is that the ideal? I don't know. It's kind of a place. So if you had life and death situations, you want that p-value to be extremely low. Okay, you want it very close to zero, because that, you want to make sure you're making the right choice. If you were talking about the people who are running the red lights over here at the intersection, I guess, people could get to a bad accident, and that's really bad, but not every time someone runs a red light is there an accident. So what would you choose? I will tell you that once you start getting lower and lower and lower p-values, it's more and more and more expensive for you to run your statistical tests. So then they start talking about, we bring in the alpha value. Okay, so we talked about the p-value being low. And then the level is called alpha, represented by this Greek symbol. Alpha must be set by the researcher ahead of time, done prior to the study. You did this prior because you were making observations, going, huh, that's strange. Huh, that's strange. Look at that, it's happening again. There's definitely observations we all would make. Now, the majority of us wouldn't go and create a statistical research about it, but there's definitely things you're going to see. On the next door neighbor app, oh my gosh, some of these people are trying to instill fear in everybody. Look, here's a bobcat, and you're looking at it going, you sure? I've seen bobcats, and those paws are just regular kitty cat paws. That's just, they're just throwing, anything like that. They're trying to get a reaction out of people because we live in a dangerous society. Okay, yes, crimes do happen. But next door neighbor app just trying to scare the old people into making sure their doors are locked. Make sure you check your locks 25 times before you go to bed. Oh, okay. So a reasonable value of alpha are 0.01. So 0.01 is a pretty good thing to go with there. Sometimes they might use 0.05 and 0.10. There's no rule regarding where alpha should be located. Alpha can be thought as the complement of confidence. If we select an alpha value with my hiccups of 0.05, we are associating that we are 95% confidence when we reject the null hypothesis. We select the alpha value of 0.02, then we're saying we're 98% confident when we reject the null hypothesis. Okay, so the lower and lower that gets, the higher the percent goes that you're able to reject the null. Lower values of alpha make it harder to reject the null. We need stronger evidence to generate a lower p-value. However, if we do reject the null, we do know some confidence is less than a chance of making a type 1 error. In fact, alpha is the probability of making a type 1 error. So alpha goes along with a type 1 error. Okay, and then let's just review real quick. Type 1 error was when we reject the null when it happens to be true. Okay, or we have evidence to show that it's true. Lower values of alpha make it harder to reject the null. Okay, we just did that. The higher value of alpha makes it easier to reject the null, and we find strong evidence we're looking for. However, we do, with less confidence, imagine selecting an alpha of 90%. That would easily reject the null, but we do so with only 10% confidence. So rejecting the null with only 10% confidence. So you think about the complement, 100 minus what they actually say alpha is. So in fact, this makes no sense. We would be finding stronger evidence for something, but admitting there's a 90% chance of being wrong. It is common for research to say the results were significant at the 0.05 level. The phrase statistical significance simply means that the null was rejected. The 0.05 level is a way of communicating a potential value for alpha. Again, ideally, alpha should be chosen based on analysis, risks, and rewards of making type 1 or type 2 error. If we think a type 1 error would be huge risk, we would set alpha very low. If we think a type 2 error would be a huge risk, we set the alpha very high. So again, type 1 error, when we reject the null hypothesis, that is true. Type 2 error, when we fail to reject the null hypothesis, that is really false. So I would definitely have page 27 as an earmark, because if it does say this is a type 1 or type 2 error, I think you could kind of decipher what is on the quiz in order to go through that. Page 30 is just kind of a summation of what we just talked about.
Hold on,
Yes.
So, hold on, to find the probability of a type 1 error and the type 2 error using the alpha, how does that work?
Okay. So the smaller you make alpha, so if you made alpha 0.0001,
Okay.
that means you're like 99.9% sure that you were rejecting the null is good.
Okay. So then does that mean, that means that we're 99 point whatever % sure that the type 1 error will happen?
It's easier to make that type 1 error. If I change that alpha to 70% or 0.70, that means we're 30% sure. So that means that if we have 30% sure, we reject our null because we set alpha so broad. It's like, think of the normal curve. You set alpha really wide, something's going to fall in there. Think about if we said, hey, we want to know, we're going to do test scores and we're going to worry about 95% of our data. If we set an alpha value of 5 or 0.05, that's 95%. That's 2 standard deviations. 2 standard deviations accommodates 95% of our data on a normal curve.
Okay, so it would be 99.9% probability of a type 1 and then 0.0001% probability of a type 2 error.
Right.
Within that context.
I like that. That's good. Yeah.
So what alpha value do you reject?
I would say 0.05 is your go-to. If it's less than 0.05, find evidence to fail to reject the null. 0.05. That's the good one. Unless they give you something, if they already gave you an alpha value in the problem that's different than that, then you use that. But 0.05 is your good default.
And if it's less than 0.05, you reject.
Fail to reject.
Fail to reject?
Yeah. Right? Fail, yeah. All right. Are we ready for page 31? This was all before break, so it's coming back to me. It's not coming back to me, sorry. Okay. So this is the place where we start having the, using mu as the mean. So there are hypotheses in this case. Mu is equal to 55. The alternative is less than 55. That's one tail, obviously, because it's directional. If it was greater than 55, it would also be one tail. If you said there is, not equal to on the alternative, that would be a two tail, and two tail is bad, we keep saying, okay? So stick with that kind of terminology. When you're creating, so it says here, we create a null hypothesis by sampling distribution. I'm on page 31. Knowing we plan to use a sample size of 100, the mean and standard error of this distribution would be 55 and 80 respectively. So you have to make sure when they are saying you have the standard error, you're using that in place of your standard deviation. Now, standard error in this scenario is the standard deviation over root n. Standard deviation of the test of the population is what we want. What did we say yesterday, though, about when do we use standard error and when do we use standard deviation? What was the big key there? Yeah, sample size. So if this is all being referred to as we have this sample, this study. I think I'm spelling words right. It still looks like I'm writing with rocks underneath my paper. We have to deal with that. So when in doubt, go to the standard error. That means you're making a less of a incorrect assumption, because as a standard error, things get closer and closer as the shaded curve. If the null is true, we would expect to see the result relatively close to the mean of 55. If we see it as an unlikely result, we call the null hypothesis in question. As such, we use the results of our sample to weigh the evidence against the null. Simply put, the farther our sample is from the mean, the stronger our evidence is from the null. So if we said, hey, we found this is our mean, and we found something way down here, that's stronger evidence that we can say, nope. So remember, on this case, they had said that our null was equal to 55. So they called this 55. So our alternative, if we were to say that mean is less than 55, let's say this is 2. That's pretty far away. Okay, so just realize that. How far away is far enough away? Well, you have the standard error to look at it, saying standard error goes in place of standard deviation. How far does it get away? One standard deviation to the right or to the left of the mean accounts for 68% of our data. Okay, if I start getting further and further and further, it means I have less and less and less area under the curve that we're talking about.
Stuart, can you write down what's the other equation from standard error?
It is this P1 minus P over N, and that's all under a square root, where at the top one, we are,
Just the sample under the square root.
yeah. So this is a whole square. This is when you have percents given to you.
Right,
Or-
and when you don't have a standard
Or
error,
if we could find a percent. If they say that we found that 3 out of 4 is,
75%.
yeah.
And then that's also if we use that one when we don't have a standard deviation at all.
or if it's a standard deviation of the sample. Okay. I would go with either of those. Well, the percent shouldn't have a standard deviation of the sample given regardless. I think that would be poor writing on our part. So I'll make sure when I take a look at the quiz, we should be good. Questions. Let's see. Let's look at anything else that we need to see here. Nothing to see here, pal. Okay. Page 33. So recall and formally define p-value as the probability of obtaining a result at least as unlikely as we obtained by random chance. Okay, random chance, again, that's what we need. Practical matter is we can represent p-value as a shaded region on the normal curve, assuming the sample distribution is normal. Okay, everything should be normal on this test. I'm not creating like bimodal stuff. Normal CDF takes place on the calculator. Are you okay with normal CDF? Do you know where to find normal CDF on the calculator? If not, here are your steps. Dude, turn my calculator off yesterday. Man. Let's let that load. Try and come on. Come on, baby. There we go. Clear. All right. Okay. So, ready? So I would, on your notes, know that you have this normal CDF. Okay. Where are we going to find it? Write these steps down. Ready? Obviously, turn the calculator on. Okay. So we go second VARS. Second VARS. You see normal CDF? On minus number 2, right? So remember, this talks about the lower and the upper. So if it's things that are going less than, your lower is going to be really small. If you're going greater than, your upper is going to be really small. And then you have your mean and the standard deviation. But what happens if we had a standard error on it? Do I plug standard error in for this value here?
Yes.
Yeah. Go ahead.
Can you do it like, can you just like write it down like how you set up the normal CDF? Because I always forget like where the numbers go.
Yeah. So let me just make one arbitrary. I just made stuff up. This is not a problem in our book. So if that's sitting on your thing, it's going to be normal CDF. And this is lower, upper, mean, and then right there is going to be either standard deviation or standard error. How do you know it's going to be the difference between the two? The standard error, they would say that you have a sample of a certain number. We did a study of 55 people. That's when we're going to use standard error. If they just said, hey, we found that we have a mean of this, we have a standard deviation of this, and we want to know where it's greater than, 12 or something, just plug it in as the normal standard deviation. But if they give you a standard deviation, but somewhere in the problem it said we sampled 55 people, 37 people, 19 people, something like that, that's where you're going to use the standard error. So look to see, standard error is going to take place when I give you some sort of sample number. There's a certain number. Okay, yeah.
What's that like the over number though? Like, is it?
Okay, oh, good question. Okay, so let's say we said created this. Our null is mu equals 30, and our alternative is mu is less than 30. Okay, so this case would be, like 0, 30, and let's say they gave us a mean of 100 and a standard deviation of 12. Then you go 100 and then 12. Okay, so because this is less than, we're plugging 0 in, or something really small. It could be even a negative number. Okay, but if I change this to say, hey, my null, let's do the exact same numbers, 30, and then my alternative, we wanted to know that this was greater than 30. That means that in my normal CDF, I'm going to go 30, big, 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 so 1,000, 10,000, a million, what, you pick something big. Don't be like, I'll pick 31. No, that's not big enough. And then again, you're 100, and then you're 12. Okay, so one is to the right, one is to the left. It all is based on this here. Does that make sense? Okay. So the normal CDF, doing all of this, will find our p-value. Okay? That's the big key, is what we're finding when we do normal CDF, p-value. P-value less than 0.05, fail to reject the null. Unless they give you a p-value different than that, stick with that. Okay? Your alpha, again, is taking place, I'm on page 34. Your alpha is taking place because you have done observations. How sure do you want to be? Okay, you have done observations, but you haven't created a test. You haven't been collecting data. It's just something you've seen over and over and over again. The walk signal going across an intersection. You notice you cross that intersection every day, and as soon as it hits walk, you have a normal walking pace, and you're like, I can't get across the street in time, and I'm walking at a normal pace. You're not some person limping across the road. You're walking at a normal pace. You start realizing you better hurry up because people aren't patient in those cars anymore. They're going to be beeping at you. They're going to run up on you. It's kind of like those movies that you see in New York. Cab is running up on you 100 miles an hour because he's going to show you. So in summary, we calculate the p-value as a percentage of the normal distribution that is farther away from the null hypothesis mean than our sample statistic. And for means, okay, this is a good one. So if we are giving you means, so you have averages, you want n to be greater than or equal to 30. If it's proportions, these are things that you want in place. You want n times p to be greater than or equal to 10, and you want n times 1 minus p to also be greater than or equal to 10. So in order for these to take place, is my sample larger than 30? Good to go. This is going to go with everything we want. Are we using percentages somewhere in our thing, or is it an easy percentage? So we have 3 out of 4, which is going to yield us a 75%, which is 0.75. And again, I'm just making these values up, but which of these two take place? If you have a means take place, can I say this is a good test? Yeah, we took a look at it. We have an average. We have a sample at 77. That's bigger than 30. We're good to go. Our proportions, we have 10% of this. Okay, well, 10% times our sample, and then our sample times 1 minus 10%, or 1 times 0.9. Are those both bigger than 10? Go with that. It's good statistics. If it's not, then we have to start using the degrees of freedom, and that is our different test. Okay, page 35. Let's just stop there. I've been talking enough. So we will pick this back up. Will someone remind me that I'm on page 35 tomorrow? And we'll take care of you there.